So the couple of things that we're going to do today, some of it's a little bit strange. We're going to use some technology to do some of the solving, which you would not be required to do on a test. I'm not planning on having technology as part of the test. But the understanding that goes with it is important to go through. So some of these questions would appear in a test. Some of them probably wouldn't, but they help us make connections in what everything's talking about. Okay. Okay. So the tide off the coast of Durban, South Africa, ranges from 0.8 feet at 9:45 a.m. to 6.4 feet at 3:45 p.m. and repeats this cycle every 12 hours. Okay, so there's 6 hours between those two. It goes from the minimum to the maximum. Think about that in terms of sine or cosine. Like, think about how much of the graph has happened in there, because that's a little bit different than the way you would have seen this previously. And so then it repeats every 12 hours. Determine an equation for this relation. So how do we come up with an equation? Well, by coming up with the A, the K, the C, and the D. Okay, so let's start doing that. How do I, like, in that description, where's the amplitude? In that description, where's the period? Where's the phase shift? So this is a big part of the connections that you're making in applications. There's a few different types of questions that you're going to see. You're probably going to see a Ferris wheel question. Those are common. And again, it gives you all of these different measurements, and you have to understand how you get the amplitude and that kind of thing out of it. So how, and there's order maybe doesn't matter. Okay, you can do these things in a different order. So maybe we aren't going to start with A, but what could we start with? Let's do it. Let's see what happens. So 6.4 minus 0.8. That's going to give us the distance between the max and the min. If I divide that by 2, yeah, that's my amplitude. Good. What does that work out to? Anybody have that? 2.8. Thank you. That's my amplitude. We're going to hold on to that for a second. We're going to come back to it, though, I think. So how about let's do D, because D is similar to that, but slightly different. What is D? Sharif? Why? Shift? But why is it 2.8? Is it the same as the amplitude? Necessarily. I mean, it could be. There's no rule that it isn't. Yep. That's the minimum. So it's not just, where did the minimum start? It's a little bit different. Hunter, what do you think?
You add the amplitude to the minimum.
And?
Which would be 3.6.
Oh, good. I wasn't paying attention. Add the amplitude to the minimum. That's a good idea. What's another way that you could find it? Roman, you had your hand up?
Well, subtract the amplitude from that.
Okay, that's another way to do it. Anybody have another way that you could do it? Whatever way works for you, that's fine. This is what I mean by making connections to the properties of the function in the graph and the AKCD values. The other way that you could do it is it's 6.4 plus 0.8 divided by 2. That's how I find the middle of two values. It's the average of those two values. The middle of the max and the min is where the zero line occurs. And that works out to 3.6 as well, I believe. So that's good. That's a nice little check that we've done everything correct. All makes sense. It all fits. What is C? before we do this, it doesn't tell us, determine an equation for this relation. Am I going to use sine or cosine? Why would you choose that?
Because from the information they tell you, it starts at the minimum and it goes to maximum.
I like it. Cosine starts at a max or a min, depending on the reflection. So that would be a natural choice. Could you start with sine? You could, but you'd have to do a little bit of extra work. It would be kind of strange. Some other applications might use sine, and some applications might use cos. Try to pick the one that's natural. I don't know that it's a matter of right or wrong, but often there's one that would be more sort of normal to use. So if we're starting with cosine, we're starting at the minimum. Where does that occur?
That occurs at 9:45 a.m.
So we're going to convert that to a decimal, which would be, no. 9.45 is less than 9.5, which is half, which is a half hour. So that's under 9:30, so that doesn't make any sense. Hunter?
Would it be 9.75?
Yeah, 9.75. And by the way, I have to go back to my A value, and since we've now done this thinking that it's cosine and it's reflected because it starts at the minimum, my A is going to be negative. What's left? K is equal to 2 pi over the period. So that's 2 pi divided by, what is the period? 24 hours. How many times will it repeat in 24 hours? Hunter, what do you think?
It would be twice in 24 hours.
Right. So what's my period?
12 hours.
12 hours. If it repeats twice in 24 hours, that's going to repeat one, right? Every 6 hours it goes to the max, to the min. 6 more hours, it'll be back to the min. So there's one cycle. So 12. It says that in the question, but I don't know how obvious that is when it says repeats once every 12 hours. That means it's the period. I mean, it kind of does, but I don't know. So this works out to pi by 6. You will notice, and this like if you're just going through the steps, then it'll work itself out, but you'll notice that when we do applications, often my K value has a pi in it. When we were just graphing, often it didn't. Okay, so that's just different, right? But notice that. Let's try to write our. Go ahead, you can try to write it. So I've decided to call it like depth at a particular time. If you use y and x, that's fine. If you use f at x or whatever, that's fine. But usually we do try to use variables that make sense, right? So d at t equals my a value times, which again, remember is reflected, times the cosine of k t minus c plus d. Now it says make a sketch of the relation, and then we're also going to graph it with technology because we're going to do a few things that would be hard to do without technology. Not impossible. It is. We would be able to do it. How do we sketch? Sketch is different from graph. Okay, I'm not worried about it being perfectly accurate, but we're going to do the best we can, and then we're going to label it. Like I'm not doing a scale, I'm not doing it on graph paper. If you were supposed to graph, then that's what you would do. You would have to come up with a proper scale. So it starts at the minimum at about 9:45. So there's 9.75, which is 9:45 a.m. And that occurs, and that depth, is 0.8 feet. And then at about noon, it's up at the maximum, which is 6.4 feet. And then after another 6 hours, it'll be back down to the minimum. So this is 3:45. I'm going to do it in the 24-hour clock, because in the end, that's going to help us a little bit more. So 3:45 is 15 point, should say 0.75. And notice that that's like 6 hours have passed. 6 more hours have passed. This is 21.75. 6 more hours have passed. And we're right about here. And so that is 3 in the morning again. So I'm going to label it that way. That might seem a little weird, but 3.75. And I'll be back up to the maximum. Doesn't say to do 2 cycles or anything like that, but I'm doing it just I can't remember exactly. Let's see. It's going to hit a maximum, but not another minimum until after it crosses something like that. Okay, now watch. So negative 2.8 cos bracket pi by 6, I think, right? Bracket x, I got to use x in the program, right? So we use t, but I'm going to use x minus pi, nope, not pi by 2, minus 9.75 bracket plus 3.6. I think that's all right. Does that look about right? That looks, this is 1, 2, 3, 4, 5, 6. So just over 6 is the max. Just under 1 is the min. Looks about right. There's my beginning at 9:45. There's my maximum just after 1,500 hours, or at 3:45 is a max, and then repeats again. And we can see where there's the end of a day at 24 hours, and the next day would start, beginning obviously. So I think everything looks good to me. All right. C, use the graph, technology graph, to determine the time span in which the coast is surfable. So the coast is surfable at a depth of over 4.5 feet. So just watch. Here's how I'm going to do this. I'm going to put a little line, y equals 4.5. It's going to give me a horizontal line. And then what I can do with this software is I can click and find these points. And that one happens after the next day. So there's sort of 2 times where it's above 4.5 feet. This is not something that you would do without technology. Okay? Not likely. But it's something that we can do with technology. So what do we have here? This is just before 2 o'clock in the morning to just after. Remember, these are not minutes. That's not 6 hours and 13 minutes. Okay? So I'm just going to give roundabout answers right now, because really what we're doing is the thinking process here that's important. So this is before 1:30, and this is just after 6 in the morning. So from before 1:30 a.m. to just after 6 a.m. And there was one more time. You know that surfers usually go surfing in the morning. That's when tide is highest. And then the other one is, well, same thing, because it perfectly worked out in the day, right? Which isn't normal, but and then so just before 1:30 in the afternoon to just after 6. So same thing, just before 1:30 p.m. to just after 6 p.m. I suppose it's possible you could be given a graph, like done electronically, and be asked to interpret it or something like that. That's possible, right? Next question. Use the graph to determine when the coast is swimmable. So under 3, so y equals 3. And when is it under? So just look at that. From midnight to just before, and then it's not. And then it's swimmable again starting around just after 7 to 10, 11, 12 to just after noon, and so on and so forth. Pretty straightforward. E, how many times a day is the depth? Exactly 6 feet. Now this is something that you could answer with your sketch. So what do you think? And this shows a good understanding of being able to visualize like the period and how it relates to the 24-hour clock in the day. So how many times would it be exactly 6 feet? 4 times? So let's see. In 24 hours, y equals 6. So I'm going to hit 1, 2, 3, 4. I missed there, but that's okay. And then the next one occurs after 24 hours. So good. 4 times. And what is the latest time that the depth is 2 feet? This is another one that would be tricky. You wouldn't be able to do this with your sketch. So we would have to do it with technology. So the latest time, you say that it's 2, y equals 2. And I'm looking here, and it looks like it happens right there just before 24 hours. So what time is that at? Oh yeah, look at that, just before. Yeah. You could, but it would be a little bit more rearranging than we've seen. It wouldn't be something impossible for you to do. Yeah. So you could try it. Last question. What is the depth at noon? Now this is something that we can use our equation to figure out. Right? So this is when t equals 12 equals, where's my equation? Negative 2.8 cos pi over 6 bracket 12 minus 9.75 bracket plus 3.6. So if it gives you the time, you can put that into your equation. That part's not so bad. Any questions so far? That's pretty much it, but I'm going to show you one last little thing. Seems easy, but some of the applications do get a little bit different, like reading through the question and translating the information you're given to those properties does take some thinking through. I want to show you something. Oh, before we do that, I'm going to find this point. So I'm going to do it by doing this. So 12 and f at 12 is my point. So there's my point at where is it? 12. There it is. 12 hours. What's the depth? And so I can see that it's about 2.53. Now I'm going to try this on my calculator. And I get negative 2.8 cos, got the bracket, pi by 6 bracket 12 minus 9.75 bracket plus 3.6. Wrong answer. Weird. Does anybody know what happened there? This is a weird quirk with calculators. Yeah, but specifically, what was the mistake? Do you know where it is, Hunter?
You didn't put bracket along pi divided by 6.
Yeah. So interestingly, these calculators, now not every calculator, some I think like this is the Casio, the other ones might be different other brands, but the Casio, if you put a number beside a bracket, it puts what's in brackets, it puts it in the denominator. If I just put a times there, then I believe it'll give me the right answer. That's all you have to do. So be a little bit careful that you try a few of these and check it and make sure you know how to put it into your calculator. You could use a fraction as well, pi over 6 instead of pi divided by 6, and that would work. Yeah, different ways of doing it. Absolutely. Okay, any questions? Just a funny little quirk I noticed doing these kinds of questions.